Hello again, this is the Math Dog. In this video we're going to look at trigonometry. Specifically we're going to look at the trig identity cosine squared x equals quantity 1 plus cosine of 2x divided by 2. So before tackling this video you really should watch my video where I derived the cosine of a plus b equals cosine a cosine b minus sine a sine b, because this proof is going to follow directly from this property right here. So let's get started. So we're trying to show that cosine squared theta is, I'm going to put that in parentheses there, quantity 1 plus cosine 2 theta over 2. So recall the property I just showed on the previous page. We're going to use this cosine of the sum of a plus b, cosine of angle a plus angle b equals cosine of angle a times cosine angle b minus sine angle a sine angle b. So the thing is, what I'm doing is I'm going to let a equal b equal theta. So now I can make a substitution. That'll be cosine of theta plus theta equals cosine of theta times cosine of theta minus sine of theta times sine of theta, because I'm replacing a and b both with theta. Well, this is then cosine of 2 theta. That's going to equal cosine squared theta minus sine squared theta, which in of itself could be a useful result. Well, so now let's look into this a little further. I'm going to say that sine squared theta plus cosine squared theta equals 1. And the reason for that, this is the Pythagorean identity. I talked about it in previous videos. But the reason for that is, again, if you have the unit circle here, say this is radius 1, this is the point 1, 0 on unit circle, and you've got a right triangle here. This is x, this is y, and we'll call this 1 because that's the radius of the unit circle. So we have x squared plus y squared equals 1, but from, and this is angle theta in here, I should probably say that's theta. So notice that cosine of theta, and from SOHCAHTOA, cosine is adjacent over hypotenuse. Well, that's the opposite side, that's the hypotenuse, so cosine theta has to be x over 1. So x equals cosine theta. Likewise, sine theta in SOHCAHTOA is opposite over hypotenuse, so that's opposite over hypotenuse, that's y over 1. So we get y cross multiply, we get y equals sine theta. So any point on this circle has the coordinates cosine theta, sine theta. But more importantly here, for this is a Pythagorean property here. X squared plus y squared is 1 squared, which is 1. Notice that x is cosine theta, so I could write this as cosine theta quantity squared plus that y is equal to sine theta, so this is sine theta quantity squared, that equals 1. Well, that can be written as cosine squared theta plus sine squared theta equals 1. Now we're not going to need a calculator in this video, but I've pointed out before in other videos that if you're going to enter this cosine squared theta in a calculator, you need to enter it as parentheses cosine theta quantity squared. Same thing for sine squared theta. You have to enter as sine theta quantity sine theta squared. Okay, well now this is the Pythagorean identity. In our proof here we have this, and I'm going to look at sine squared theta. Notice from here, if I subtract cosine squared theta from both sides, I get, that goes away, so I get sine squared theta equals 1 minus cosine squared theta. So now I'm going to make that substitution right here for sine squared theta. So now bringing this around, we have cosine 2 theta equals cosine squared theta, and I'm going to replace sine squared theta with minus the quantity 1 minus cosine squared theta. So cosine 2 theta then is going to equal, notice that's going to be, using your distributive property, that's going to be cosine squared theta minus 1 double negative plus cosine squared theta. So we have cosine of 2 theta equals cosine squared theta plus 1 plus cosine squared theta. So we get cosine of 2 theta equals 2 cosine squared theta minus 1. So now I'm going to solve for cosine squared theta, so I'm going to add 1 to both sides. And I'm going to get cosine 2 theta equals plus 1 equals 2 cosine squared theta. Alright, so now solving for cosine squared theta, I am going to divide both sides by 2, so we get our final result. I'm just going to swap sides here. I get cosine squared theta equals the quantity cosine 2 theta plus 1 over 2. And that concludes our proof. So we've shown that cosine squared theta equals cosine of 2 theta plus 1 all over 2. So here's some additional info where this property might be helpful. That would be in calculus. So if you haven't had calculus, you can stop watching the video, or if you want to continue, you may just go on to the end. But the reason this is valuable is if, say, I had to integrate cosine squared x dx, that's pretty difficult to integrate, but if I write this property, cosine of 2x is relatively easy to integrate. So if I have cosine squared x dx, I will integrate this, so I would have the integral of 1 plus cosine x dx. Let's actually progress this. So I could factor out a 1/2 here, and then I have 1 plus cosine 2x dx. And I guess the way I like to do this is probably I would like to write this as 2 integrals just to keep track of things. So I have 1/2 of the integral of 1 dx, which is just dx. Let's actually change that to, that's just 1 dx, but that's dx, plus the antiderivative, I should say the antiderivative here, of cosine 2x dx. And then I'll just do one at a time. So the antiderivative of dx is going to be x plus some integration constant c, I'll call it c sub 1. And then the other antiderivative is cosine of 2x dx. Well, here I'm going to do a u substitution. I'm going to let u equal 2x. So du dx is 2. Therefore, we have 2 dx cross multiplying is du. So dx is du over 2, and that's what I'm going to use then in my substitution here. So here I now can write cosine u times du over 2 because I'm replacing dx with du over 2. So now, half, parentheses or brackets, the antiderivative dx we said is x plus c sub 1. And then the antiderivative of cosine 2x dx, which we found to be 1/2 sine 2x plus c sub 2. Well, we can combine the integration constants into one big integration constant. We'll say let c sub 1 plus c sub 2 just equals c. So this will be 1/2 x plus 1/2 sine 2x plus c. And if you like, we could factor out a 1/2, the quantity x plus sine 2x plus c. And that is our result. So when we use the property here of cosine squared x equals 1 plus cosine 2x over 2, it allows us to do a relatively easy integration, and so then we can get a result directly. And this concludes the video. So if you found this video informative and you liked it, please give it a thumbs up and consider subscribing to my YouTube channel, The Math Dog. You may share the content of this video with others if you like, and I would appreciate that.